Hey everyone, can you hear me okay? Yeah? Okay, let's get started. So first of all, thank you for still being here with only a few hours left of the conference. My name is Andrei Ermilov. I'm a software engineer here at Microsoft. I work as part of the Partner Catalyst team, and what this team does is very different. So we engage with innovation labs, with startups, and with partners around the world, and we try and solve the most difficult problems there are. So we look at what needs to be done, and we use the latest technologies to make it work. So today I'm going to be talking about an engagement that we did with Guide Dogs. This is an organization in the UK to help the visually impaired. And specifically, I'm going to be talking about the speech recognition solutions that we did for this application. But before I go there, I want to step back a little bit, and I want you to really think about the last time that you were walking in a city. You could be even here in Seattle when you were walking to this conference. And it was pretty straightforward. You knew where you were going. If you didn't, you just looked at your map and you kind of realized, these are my next steps now. But imagine doing the same walk again, but without being able to see. What are the things that cross your mind at this point? What are you experiencing? It's a very, very different experience. And us as a team, we actually blindfolded all of our developers and we put them on the street just to see what a blind person would feel when they're going through this experience. So simple questions like, where am I? Where am I going? What if I bump into someone? Or, how close is the curb? These are things that you just don't know when you're in this situation. And so we wanted to use technology to help people be able to answer these questions and be independent to navigate cities. And so what we've done is we've created an application in combination with a headset which tracks the movement of your head at any given point. And so with spatial audio, we can tell you where objects are around you using the audio. So for example, when you're on the street, instead of saying that there's a Starbucks in front 200 feet on your right, you hear it spatially. It just says Starbucks audio, and it comes towards you. You feel it as if it's outside of your head, Starbucks coffee, and you know exactly how to orientate yourself. So if you have 2 or 3 of these points of interest around you, you start building this mental picture that we normally do with our eyes, but when you can't see, you need these audio cues to understand that, oh, okay, Starbucks is there, convention is there, I kind of know where I am, I know where I need to go next. But here, this is a very good example of how things work right now. So having a dog or a cane is very critical. They use them to be able to navigate, to make sure they don't bump into curbs and so on. But when they have to use mobile phones, that's how they use them. Think about having to use your phone while walking with just your thumb. It's pretty difficult, right? Even with the UIs right now, it would be quite difficult to figure it out. Now, if you add accessibility tools on top of that, it's even harder. You need to double tap, you need to triple tap. While you're walking, it simply does not work. And so what we did is we had to create an audio-driven interface for this to work. You had to, because you already had the headset on their heads, we wanted to allow them to say voice commands that are very easy and very fast for them to respond. We chose to do iOS because it is the best accessibility tool on the market right now. iOS phones have that. And so like I said at the beginning, our team is all about solving the problem. So if we had to build an iOS app, we did it. And so let's talk a little bit more about speech recognition for iOS. If any of you have tried to do this, you'll see that it's actually not that easy to do speech recognition. When we developed it, it was for iOS 9, so there was no official SDK open. You had to use third-party, and you had to rely on other plugins for that to work. Of course, for our scenario, we had many constraints and requirements. It has to be fast. It has to work. If it doesn't understand them while they're navigating, that is a terrible experience. You don't want them to be frustrated. And then also, you needed to have silence detections. You needed to know exactly when they stop talking. And also, to be able to extract complex phrases. People have different ways of saying the same thing, and we wanted to make sure that whatever they were saying while they were out there, it worked. And so here are a few options that you can do right now. The first one is Open Ears and Rapid Ears. This is a third-party plugin. You pay a license fee for the whole plugin, so it's only like one-time fee. That's a quite good option. The quality, however, was not that great. When we started experimenting with users on the field, we saw that most of the times they didn't really get what they were saying, and it caused frustration. And then also, this has an offline mode, which was great. It had a built-in silence detection, but it relied on a predefined array of words. And so if you want to do complex extraction, it simply didn't work. If your app just does like play, stop, just these simple commands, it works. But for our scenario, this wasn't good. I put iOS 10 SDK. This was not released, but in case you are thinking of doing it right now, this is a good option. It has a great quality. It's only online, so you will need to have an internet connection. It has no silent detection. We have to implement that in code. But the service is throttled by Apple. In the documentation, it simply says if you're using it too much, they will shut you down for a couple of hours. Of course, in our scenario, this was completely unacceptable. You can't just have that stopping while they were using it in the cities. And last one is the cognitive services, speech to text. This has great quality. It's online mode again, so that was one of the fallouts of this. It has built-in silence detection, and most importantly, it has complex intent extraction. And that's using Lewis. You've probably seen some of the talks here about Lewis, but that is the language understanding intelligence service from Microsoft, which allows you to look at words and to look at phrases and extract the intent out of that. And it's based on a machine learning model that you train. So you can make it specific for your scenario, and this was perfect for us. So now let's look at the architecture of this solution. We made it in 3 simple layers, so that the first layer, which is the speech recognition, it had to have partial recognition. So while the user was speaking, we needed to know what are they saying. And then in a second layer, we have a local dictionary. This is what really increased the speed of the speech recognition, because as soon as it matched a command with something that we knew they're going to say, we just executed the command. You didn't have to wait. You didn't have to go online and figure it out. We just executed that. So for example, if you say, where am I? The partial recognition will go where, then where am, and where am I? And where am I comes, and then it matches with a local dictionary, you would execute the command straight away. You don't have to wait. In case the command was more complex, if you didn't have this predefined commands, you would go to Lewis. And this will have a round trip online. It would extract the intent, and then if that matches the command, your state machine in your app would realize what that command is, and then it will issue it. And so let's just do a quick demo here on how this looks like. So let's see if this switches. OK, great. I have here the code. This is completely open source. I will share the links later on. But you will be able to download this and give it a try on your iPhone at any point. So here, let me just show you how this looks like. It's a very simple app, but it only shows, it wants to show the principle behind it. So you have 2 tabs down here. You have Cognitive Services and Speech SDK. That's because you have an implementation with Cognitive Services, but in case you don't want to use that, you can use the Speech SDK. So it just shows, with that architecture, how you can have both technologies in one place. So I'll show you a simple demo now. Over here, you have the partial recognition, and this will fill up as soon as I start talking. And action issued here is when the action was issued. So please have a look at the first command I'm going to do and see just how quick that goes. So let's give this a try. Where am I? OK, so it picked up where am I straight away, and it issued the command. That's because the local dictionary already exists on the app. And you don't have to wait, like when you do with like Siri or Cortana, when it has to think for a few seconds. That doesn't happen here, because we don't have to go online to issue this. So we can do things like, what's around me? Again, this was in the local dictionary, so the command went straight away. But if I see something more complex, what are the points of interest around me? OK, so what happened here, this was a more complex phrase. But what it did is it didn't match it locally, but it went to Lewis and said, OK, here's the phrase. What do I do with this? And the intent is that the user wants to orientate themselves. So it came back. It's still, the round trip was about a second, 2 seconds delay. It's still really, really quick if you think about what's happening in the background. So let me go into a little bit of code here. This is all written in Objective-C. And if you go at the links that I'm going to share later on, this is the GitHub repo. And in here, you will have step-by-step instructions on how to get started. This is including how to get started with Cognitive Services and Lewis. So it will tell you, like, for example, here, how do I add the intents? What are the points of interest around me? What is my current location? You just train your model so that it understands all of these commands. And at the end, you just add your keys into the app, and you're good to go. So let's show you the code now. Okay, so here we have two view controllers. One of them is using cognitive services. The other one is the iOS 10 SDK. In here, to initialize this is very easy. So you just create a microphone client with intent. Intent means we want to put Lewis on top of it. And then the framework does everything in the background. So as soon as one of the commands is complex, it goes to Lewis and comes back with it. And then the protocol itself. This is the important bit. This is when you have the callbacks that happen while the user is speaking. So on final response received, this is when silence detection was hit, or the user just said, stop listening to me. That's the final phrase. And so it looks at this, and then it's simply, what it's trying to do is it's trying to match this locally. So if the phrase was recognized, then it just issues it. If it's not recognized, it just says, now we're reaching to Lewis for intent extraction. So that happens in the background automatically. And then the next callback is on intent received. This is when it went to Lewis and it comes back with intent. It's just a JSON payload. So here we're just using NSJSON to look at the object. It comes back with a couple of intents. And then you can take the score and the intent of each of these and have a look at it. So the highest one with a certain confidence level, this is where you can set and say, I only want to issue commands that are over 90% sure, for example. Don't issue anything else. This is where you can add it, and you can filter out everything else. And then the other one is the partial response received. This is while the user is speaking. It'll come back with, when you saw when I said, where am I? Again, it came back with three phrases, where am I? And so this is what this is doing. This is trying to match and say, do I recognize the phrase that it is right now? And this is very simple, because we just have a dictionary with all of these exact phrases and then the action associated with it. So it's a very fast lookup. It doesn't hurt the performance of your app. It looks if it's in a dictionary, you execute the command. If it's not, you don't, and you keep going forward. And that's it. This is all you need to get started with cognitive services. You simply need a few CD keys, a few keys. You put them in, and then you get started. On the other side, now with the speech SDK, this is a bit different. In here, this is the iOS 10 way of doing it. So you need an audio engine. You need a speech recognizer. And here, you also need to request authorization as soon as it presses start listening. You've seen this in many, well, probably some other apps when it says, do you want to grant access to this app? And here, you just grant access to the microphone. And then what happens in here is when you do the start listening button, it creates a task. Let me show you how this task looks like. So it initializes an audio session, initializes an input node, which is basically the microphone. And then you create a speech recognition task. In this task, over here, you see this Boolean, which is very important. It should report partial results. If you put this to no, it means you won't get partial recognition while you're talking. So this is a very important flag to set. And then when the flag comes back, they have this Boolean, which says it's final. And this will tell you that it's the same as cognitive services, just wrapped in a different way. But it says this is the final response or not. And so we do the exact same thing in here. We try and recognize the phrase. And then we say, if we recognize it, we issue the command, and that's it. Like, it's final. We close this. We don't have to listen to the user anymore. We just wait for the next command. If it's not final, this is where this is a bit different. We get here, and at this point, they said something we don't know. We don't know what it is. So we go to Lewis. And to do that, it's a very simple post request. This is the URL that you need to go. You need your Lewis app ID and Lewis subscription ID. Again, on the GitHub, it will show you how to set this up. And then that's it. You get you send this request with a string, and then it comes back with a response saying, I think this is what the user wanted to say. And you go through all of these, you pick up the highest intent, and then you try and match the action. If the action is matched, then the action was successfully issued using Lewis. I can't show this on the emulator because there is a restriction with Apple that iOS 10 Speech SDK does not work in the emulator. So it only works on a physical device. But please feel free to grab me later, and I'll show you how it works on the phone as well. So OK, that's with the code. So let's get back to this. Right. Oh. Right. Now, call to action. This is all open sourced. If you go to that GitHub repo over there, you will see the code that I've just demoed. You can easily take that, implement it in any application that you want, and start from there. There's also a blog that I wrote. So on the second one, that's the real-life blog posts. This is from our team, and when we just talk about real-life stories. And this will be a detailed explanation of everything that I just told you today, step-by-step guidance, how to get started, and all of our learnings that we had while doing this project. Again, please find me around during breaks, and I can show you the demo. I can talk about more. And if you do have a project that you need to do speech recognition on iOS or any other platform, you would like to learn more about what we did, just reach out to me, and I can help you. So that's it. I think we have time for a few more questions. Any questions? Yes. Sorry?
Where have you tested it? Where you get the blind people?
Yes. So because we work with the UK guide dogs organization, most of them came from the UK. So we tested in Reading, in London, and kind of the areas around there. But we also had a few tests here in the US. So that's pretty much our base set of users.
So you're based in the UK or the US?
I am based in the US now. I was based in the UK, yes. I have recently moved. OK, that's great. Thank you very much.